Okay. So, let's do the first one. Okay. What do we do? Just a normal stoic. Okay, turn on your cameras, guys. Nesh, Harshit, Rajin, Sharvari, Twisha. All right. Okay. Okay, let's start. So for this one, what do we do? This is just a normal stoic, right? Where you can go from, they give you the grams, right? They give you the grams of this. You can start from there. C8H8O3. And you want to find what? The grams of that thing. So what do you do? 1 mole over the molar mass of that. And then the mole ratio. One mole of you want to find HC7H5O3, 1 mole of C8H8O3. This cancel out, and then you have to find the molar mass of the salicylic acid, which is actually given to 138.12 grams over 1 mole. And your answer again, 366, 0.272 grams of HC7H5O3. Give your 1 point. If you get them, if you set it up correctly, give yourself 1 point and the value. Any question? No? Okay.
Is that question just 1 point?
Just 1 point. Okay. The student experiment result in 87% yield. 87% yield of the dry. The student suggests some of the crystal dissolve in water during the rinsing step. Is it consistent with the percent yield? See, when you rinse, right? After the student filter this crystal, he or she rinse with distilled water. So what's gonna happen? Think about this is the crystal rinsing, right? So some of the crystal mix with water and leave the crystal. So there would be what? Less of the crystal, right? So you have what? Less of the yield. That's why it's not 100%. Instead, it's just 87%. Okay, and then what you're going to say? Yes, it is consistent, right? And then why? Because acid, this is what? This is an acid, right? And this acid is soluble in water. Okay? It is soluble in water, and some of the crystal might what? Might dissolve during the rinsing and leave the what? The precipitate. That's why the mass of the precipitate is lower. And this lead to a lower percent yield. Okay? Because you're supposed to have 100%. Okay, but you're only, yeah, Rihanna?
So I didn't say about it being like soluble, like I just said that since the percent yield is not 100%, that means some of the HC7H5O3 was lost throughout the filtration process, which is why the students claim this.
Filtration. You said filtration. The student did not say it's during the filtration. It said during the rinsing. So if you have said that and you say during the rinsing process, it should be right. Okay,
If I just said throughout the process, would that still get the point or no?
that should be fine. Yeah.
Okay.
But so that's gonna give you 1 point. But because you said filtration, that will be wrong. Okay.
Okay.
Any other question? Now, given the C. So C has 2 points. Okay. You want to find the Q, right? So it's what? You start from 25 degrees Celsius to the melting point and you melt the crystal completely. So if you draw the graph, first you increase to the melting point and then you melt it, right? So the slanted one will be Q equals to MC delta T. This one Q equals to M delta H. Now again, M depends on the whether it's mole or mass depends on the C and delta H. So if you have even one of this correctly set up, so let's increase the temperature first. So for A, you have Q equals to MC delta T. What is the C? Per gram, right? So we're just gonna take the grams. 0.105 grams. The C is, and delta T is final minus initial, which is 159 minus 25 Celsius. And this gives you 16.5 joules. Okay, this is where you just increase the temperature up to the melting point. In the second process, you're gonna start melting it. Gonna melt it. So if you melt it again, you do Q. You do Q equals to M delta H. Now again, M can either be mass or mole. You have to look at the unit. So this is per mole, right? This is per mole. So you have to convert the 0.015 to moles first. Okay, so you can say 0.105 gram divided by, what's the molar mass of that thing? 138.12 grams per mole. So grams, cancel out, mole's gonna go on the top. Multiply with the delta H, 27.1 kilojoules, right? And that gives you what? Someone? 0.0206, right? And that is in joules. Now, oh wait, that is in kilojoules. Okay? If you have any one of this, give yourself 1 point. Okay, any one of this, give yourself 1 point. The second point you're gonna get is when you add those two together. Okay, so the total Q would be 16.5 joules plus, you have to convert these kilojoules into joules before you add them. 20.6 joules, so 20.6 joules, that gives you around 37.1 joule. Yeah, Raf?
Did you have to draw the graph too?
No.
Okay.
Any question? Yeah, Saket?
How did you get 27.1 kilojoules?
It's given on the top.
Oh, yeah, okay.
Any other question? No? So that's how you make sure to what? Have different color pen where you are grading yourself, okay? Okay. So D. Explain why the melting point of salicylic acid is higher than methyl salicylate. Now, who's gonna tell me your answer? Ananda, what would you say?
I said that both have LDF and dipole-dipole interactions, but salicylic acid has two OH bonds, which allow for it to form more strong hydrogen bonds. And hydrogen bonds are very strong in comparison to LDF and dipole-dipole. So
So
they're
the
able to.
best thing is not to mention how many hydrogen bond. Okay, because you guys are going to be confused. See, so you cannot say there is two hydrogen bond. This is not hydrogen bond.
Or
Okay,
they can.
but each of this can form three hydrogen bond. Each of this part. Okay, so do not talk about how many hydrogen bonds are being formed. Okay, because that's just gonna confuse. Like that first, you're gonna get it wrong, and that's why I just say it has more. This one has more hydrogen bond sites. Okay,
All right.
that's how you're gonna say.
All right.
Okay, everyone makes sense. So the way you can grade, okay, first you're gonna say that salicylic acid have more hydrogen bond sites. Second, you're going to say because of that, the intermolecular force is higher or stronger, which causes the melting point to be higher. Make sense? Now, how many hydrogen donor do you have here? You have one hydrogen donor. How many hydrogen acceptor do you have here? You have 1, 2, 3 hydrogen acceptor. Okay, in hydrogen bonding, you have what? Hydrogen donor and hydrogen acceptor. The hydrogen donor is hydrogen connected to phone. The hydrogen acceptor is the phone itself. So 1, 2, 3, right? So in this case, you have what? 1 hydrogen donor, 3 hydrogen acceptor. If you want to talk about numbers, this is how you say, okay? This one, you have what? 1, 2, right? So you have 2 hydrogen donor. And 1, 2, 3 hydrogen acceptor. But to make simple, just say it has more hydrogen bonding sites. Any question? Make sense?
How do the points work for this? Is just
Just
One
one
point.
point.
All right.
Just 1 point to state that it has more hydrogen bonding sites. Okay. Now find the pKa value. Find the pKa value. Yes, Rihanna?
Is it possible for you to go up to question C again? I just wanted to see one of the equations that I wanted to write down.
Yeah.
Okay,
You can take a picture.
I got it. Thank you. I was just writing it down.
Okay. So for this one, how do we find the pKa? How do we find the pKa? We have been talking about this for, I think it's the 10th time now. We look at yes, Trisha,
The half equivalence point?
the half equivalence point. So this is the equivalence point, half equivalence point at this. The pKa is 3. Okay? So if you have pKa 3, if you solve 1 point. Now they're asking you, when the pH is 4. So this is the half equivalence point. When pH is 4, that means they're talking about this point. Right? When pH is 4 now, who's gonna be, yes, Sharvari?
I wanted to ask if it was okay if I said like 3.1.
That should be fine.
Okay.
But try to, yeah. But it's 3, no? Oh, 3.1 should be fine too. Okay. As long as it's around there. Okay, now, okay, at pH 4, which is gonna be more, the conjugate acid or the conjugate base? pH become higher. What do we know at the half equivalence point? pH equals to pKa. If pH is higher, what else do we know at the half equivalence point? Acid equals the conjugate base. So if you have higher pH, then what's going to be more? Disha?
There's gonna be higher conjugate base.
There would be higher conjugate base. Now, how would you guys justify it? So you know that this is going to be higher. Why? Now you can just talk about what we talked before. You can say what? The pKa is at 3, right? At the pKa, the acid and the conjugate base has the same concentration. So when the pH is 4, what? The conjugate base has more concentration. That's it. Okay? You're going to get 1 point.
Could you repeat the answer for that question again?
Okay. So you want to say, wait, I'll just like read it. The conjugate base, right? The conjugate at the what? At the half equivalence point, pH equals to pKa, and the weak acid, so you want to mention the weak acid, is equals to the conjugate base. Okay, at half equivalence point. Because 4 is more than the half equivalence point, which is more than the pKa, which is the 3. That means the conjugate base, which is this, you have to mention that again, is going to be more than the concentration of the weak acid. Make sense? Yeah, Anaya? Inaya too, sorry.
For like the explanation and like the justification for your response questions, do your answers have to be like in full sentences or could you do bullets?
Like what bullets? Depend.
Like, does it have to
Like-
be like do you have to do a
Like let's say
paragraph?
you
or
have
can-
to, if you have 2 points, you can do bullets, but don't just like put keywords and then put in bullets your
Okay.
keyword. That doesn't make
Okay.
sense, okay? Okay,
Okay.
but if you have like 2 sentences and then you don't want to just continue them, you can put them in bullets. Okay. Okay, G. The students research benzoic acid and find that it has, okay, now how do you find pKa? You're given with the Ka. So pKa is negative log of that numbers. And that gives you what? 4.20. Okay. Again, 3 suffix, right? Remember? So this is 1 point. Okay. Now we have the what? We have the graph for salicylic acid. And they research a new acid, benzoic acid, right? Sketch the curve that would result from this titration of benzoic acid, right? And the pH starts from 3.11. Now for this, you're going to have 2 points, okay? The first point is that the starting point and your pKa point, okay? So starting point should be 3.11, so maybe somewhere here, right? And what was the pKa? At half equivalence point, so 10, 5. At this, it should be 4.2, maybe somewhere here. Okay, so this is gonna give you 1 point. If you have this is your 1 point already. The second point is that you want to make sure, see, how do we know what will be the volume needed? Because both of them has the same number of moles, that means the volume of NaOH also gonna be the same, right? Or do I need to show the calculation for this? No, right? You guys understand, right? It's gonna need the same amount of NaOH as the salicylic acid. The volume at equivalence point does not depend on the type of acid. So if you draw, you bring this up to here and draw the equivalence point there. This is your second point. And you can just follow this, okay? It doesn't matter. You can just follow this. Even if you put this a little bit above, it still doesn't matter. Your points are your equivalence point and the starting and the half equivalence. Yes, Rihanna?
Is it possible for you to show us an example of when, like, how we would do it when the concentration and stuff, like the stuff that they gave us, is not the same as the NaOH? Like, how would we figure out the ending volume?
Okay. So not ending, the
Oh,
equivalence point,
equivalence
right? Okay, so let's say we change the concentration of the benzoic acid to be 0.015. Okay, now what do? You find the moles of that. So multiply that, get the mole, please. 0.02 times 0.015, that gives you 0.0003 moles, right? And what is the concentration of NaOH? That is that. So this is the moles of what? This is the moles of benzoic acid. And at equivalence point, the moles of benzoic acid would be the same as the strong base. So this is also going to be the moles of strong base. So to get the volume, you do what? The mole over the molarity. That gives you 0.015 or 1, 2, 3, 15. So let's say there is more to this graph, okay? So in this case, your equivalence point is going to reach at 15. And then you're going to go up. Make sense? Okay. That's how you get the volume at equivalence point. Any question? Make sense what are the points you're looking when you're drawing titration curve? Your starting point, half equivalence point, and your equivalence volume. Okay. Anyone got 10 out of 10? That's okay. That's okay. Yeah, you got 10 out of 10 out of?
Wait,
No.
how many points was the last one out of part H?
Oh, it's 2 points, right? 1 point was for if your starting point and half equivalence point. Second point is for this equivalence line that at that volume. Okay. Next. Anyone? Vanessa, what do we say? Louder though, Vanessa. Are hydrogen oxidized or reduced justify in terms of oxidation number?
I said it was reduced because the oxidation number in CH3OH is +1, and in the products it's 0.
Okay, give yourself 1 point. Okay? Okay, now Lewis structure. Let's just review the Lewis structure. So 4 plus 6, 10. Give 1 bond first. -2. Make the sides happy. Who is the side? The central is least electronegative. This is the central, so I'm going to make this happy first by putting 6. Still have left 2. I'm going to put on the carbon. Now, who's not happy? Carbon is not happy. Carbon needs how many more? 4 more. So carbon is crying. So oxygen is going to go and share 4 electrons. That means making triple bond. Okay. 1 point. Okay. Now, for C, you have 2 points here, okay? Please, whenever they ask you to find delta G, delta H, listen, delta S, okay? The first thing you want to say, when it's product minus reactant, you have to show the formula. The formula itself, it's 1 point. Don't just go directly put in the numbers, product minus reactant. You have to show the formula and then you're gonna get a 1 point. Okay, so you can say what? Delta H reaction equals to sum of, yes, Anvika?
Oh, wait, never mind. I think I get it.
Sum of, wait, sorry. Sum of delta S of what? The product minus sum of delta S of the reactant. Okay? And then what is the product? Carbon monoxide and 2 hydrogen. So you want to delta S naught of carbon monoxide, delta S plus delta S. Oh, because you have 2 hydrogen, make sure to put 2 times delta S of hydrogen minus delta S of CH3OH. Which delta S of CH3OH. If you have this, give yourself 1 point. If you have this, give yourself 1 point. If you miss this, just put there -1. Yeah, Rihanna?
I only have the top equation. I didn't do the bottom one that you did. Do I still get a point for just writing the top one or no?
No.
Okay.
Okay. This two gonna give you 1 point. Now, once you plug it in your number, you're gonna do what? 198 plus 2 times 131 minus 240. This is gonna give you 220 joules per Kelvin mole reaction. For the last step, give yourself 1 more point. Yes, Anam?
Do you always have to write the equation on the FRQs if you have to like do the math?
Yeah. Okay. So see, most of you were able to what? Were able to solve it. So try to give some gaps, okay? See, if you're running out of time, right? You don't want to run out of time writing all the equation, all the formulas, right? So what you can do, you know that, oh, you're gonna start with this number first. You know you are out of time, so you start with this. And then at the end, because you know you have extra time, you can go back, put on the top this thing. Okay? If it's worth of 2 points, you're gonna get both of the points. Okay, calculate delta G for the reaction are independent of temperature. So you have delta S, you also have delta H, right? So you can just plug it into. The one thing you need to always, most mistakes happen when you do not convert the joules into kilojoules. Make sure to have your delta S in kilojoules. So delta H is 90 kilojoules per mole minus the temperature 375. Convert the delta S, okay? So it will be 0.220 kilojoules per Kelvin. This is also Kelvin mole reaction. And then you do the math, you're going to get 7.5 kilojoules per mole reaction, and this gives yourself 1 point. Any question? Mm-hmm.
I didn't do this, but I was just wondering because I know for like other classes it works like this, but like example, you got the answer wrong in part like on part I, but then since you need part I to go to part like 2I or whatever, if you plug in that same answer and you still like go to kilojoules and everything, like do you still get and you get the answer wrong, do you
Yes.
still get the point?
Yeah, you're gonna get the full point, yeah. Let's say instead of 8, you got maybe you got 820 on the previously, right? But make sure to what? Convert the 820 into kilojoules. Okay, and if you do that, whatever your answer here is still gonna get point. Yes. Harshit.
Yeah, so why is it two significant figures?
Okay, put 3. Okay. We don't
Okay.
care about the sig figs for now.
Okay,
As long as you have 3, you should be good.
okay.
Okay. Okay. Use information from the particle diagram to calculate partial pressure of CO when the total is 12 atm. So we know that it's the mole fraction, right? So partial pressure of CO is the mole fraction of CO. How many CO you have? 1, 2, 3. Divided by 4, 5, 6, 7, 8, 9, 10 times 12.0 atm. And that gives you, what's that? 3.6 atm. Just, well, 3.60 atm. Again, just keep your answer in 3 sig figs. You're not gonna get it wrong. Because if the answer wants a 2 sig fig, you're still gonna get point. If the answer wants you to have 4, you're still gonna get point. Then give yourself 1 point. For E, it's Kp, right? If you put bracket -1, okay, it's not bracket, it's the P. Product of a reactant. Make sure you have the square on the H2. Okay. 1 point. These are in equilibrium. Because this is in equilibrium pressure, this is not initial pressure. Yes, Sharbari? Hello? Hello, yeah?
I wanted to ask if it was okay if for part D you left it as a fraction.
Fraction? What do you mean?
Like when I put it in my calculator, I got 18/5 and I just kind of left it like that.
Make sure to fix your calculator, okay?
Okay.
Put it in decimal. Okay. Okay, for F. And then because these are equilibrium mixture, that means this pressure are at equilibrium. You guys can directly plug it into that formula on the top. And Kp would be 4.2 times 8.4 squared over 2.7, 110. No unit. Another 1 point. Okay, the last one. Now, this is 2 point. Who wants to try? Anish, you there? You wanna try?
Yeah. Okay,
So,
so I said because the reaction will decrease the number of moles of CH3OH if the volume is doubled. When volume is increased, pressure is decreased. When the pressure is decreased, the reaction proceeds to the side with the most moles of gas. And Q is less than K because the pressures of the products are decreasing. The reaction will use up the CH3OH to reestablish equilibrium.
1 point. You did not talk about the Q. Okay, so you have to talk about the
Q is less
Q.
than K.
But you have to show, you did say it's less than K, but you have to justify. How is it Q less than K? So what do? You
Besides
remember,
the
you guys can, it's easiest if you can just what? Go and plug it in. Remember I showed you last time I showed it to you guys how to do it? You do what? So because this is half, what can you do? So the Q would be 1/2 of the P of CO times 1/2 of P of H2 whole square over 1/2 P of CH3OH. Wait, let me explain. Before I do this, let me explain first the question, okay? The volume of the pressure double, right? When the volume of the pressure double, what happened to the volume? So what am I saying? The volume of the container double, what happened to the pressure? It become halved, right? So all the pressure of this going to become half. That means now it's not at equilibrium anymore. So that's why we do Q equals 2. And we have all the pressures. Okay, and then we're going to see what happens. So half of this going to cancel out, right? And this one will be square, right? So you're going to have 1/4 of P of CO times P of H2 whole square over P of CH3OH. This is how you can show, Anish, that your Q is in fact less than K. Okay? If you showed this, you already got 1 point. Did anyone do this though? Ayana? Okay, those who did this, good. So that means Q less than K. And because Q less than K, the what? The reaction will proceed to the wait, sorry. We always do K so we can know the direction for sure. So who's less? So the reaction going to proceed to the product. And that means what? The CH3OH will decrease. Make sense? Yeah? 1 point there and 1 point to the sentence that I just said. Because Q is less than K, reaction going to go. Yes, Rihanna?
So what you're saying is that to get both the points, we have to say that both Q is greater than K, and we also have to show like the math that you did.
Yes, to confirm. You have to confirm that Q is less than K.
Okay.
Right? How would you confirm with
I
that math?
did because of Le Chatelier's principle. Like I used that.
This is because they also want for you to talk about the Q.
Okay. Okay.
Any other question? Yeah, Ara?
All I said was it was basically what Anish said, and like the side with more moles gets favored. So do I just get 1 point?
You just get 1 point. Okay, those you can say those things. You don't say those things. Those are for MCQ, not multiple choice. Okay, where you don't because if you keep doing this for every question, if you have multiple choice and you do this, it's gonna consume your time. So that's kind of like a trick to see which one has more moles. Okay, and that's also honors chemistry way of learning. Make sense? Anyone got 8 and above on this?
What was the total points for this out of?
This is 10 points. Okay. 8 and above the previous one as well. Question 1. Anyone got 8 and above? Okay. Good. Okay, so the next one, configuration of aluminum. Well, this is very simple. You can either, because they did, you can either do the what? You can either do the noble gas or the whole thing. Okay, which I don't think there will be any one of you that's gonna miss a point on this. You shouldn't be taking AP Chem tomorrow. I mean, like what, on Tuesday if you do not know how to do this. Yeah, Nanta, you can do both of them, okay?
They both work, even if it's
Yeah.
like ground state.
Yeah.
All right.
Ground state is this.
Yeah.
Excited state is when it goes to what? Yeah. It's a complete though, so but I would have thought that they only want this, but they also give this as the answer key, so they should be fine. Okay. No one got this one wrong though, right? Right? Okay. Okay. Now, why is aluminum atom is larger than aluminum ion? Sakit?
I put that Al3 plus has less electron shielding than Al, but it still has the same number of protons. This means that Al3 plus has a greater effective nuclear charge, resulting in it having a smaller radius than Al.
Wrong. Ayana?
Sorry about last time, my mic wasn't working, but for this one, I said the radius of Al atom is larger than Al3 plus ion atom, since Al atom occupies more energy levels than Al3 plus ion.
Correct. Correct. So whenever,
since it has a, oh, sorry.
Yeah, you got the point. Okay, so whenever they talk about the ions, okay, to be safe, make sure to write the configuration. So if you do configuration of Al3 plus, if you do the configuration of Al3 plus, what you're gonna get? You're going to actually remove both of this. So basically, Al3 plus is what? On the second shell. Okay, it's on the second shell, so you have to mention the number of shell. No mentioning of the number of shell, not gonna give you point, no matter how good your explanation is. It's not about the number of proton, right? It's not about the shield. Well, it is about the shielding, but the most important point is the number of shell. Okay, so you want to say that what? Al occupy the third shell while what? The valence electron of Al occupy the third shell while the Al3 plus occupy the second shell. Now, if you want to be more like then you can say what? Therefore what? The lower the distance of the what? Of the Al3 plus from the nucleus means what? The Coulombic attraction is stronger, which causes the size become smaller or the radius become smaller. Always talk about Coulombic attraction. Make sense? So if you do not give yourself, if you did not write about the shell, then subtract 1. Okay, so this is preparation of solution. Okay. Let's hear it. Inaya too? Yes, Rihanna?
I was just gonna ask if you wanted me to say like what I did.
Okay, sure.
Okay, so the step 1, I just used the one that was on there, use weighing paper to measure the determined mass of the solid. And then for step 2, I said measure out the determined amount of the solution of silver ions in a graduated cylinder to get a precise measure.
Wait. Can you slow down? Can you repeat that?
Yeah. Measure out the determined amount of solution of silver ions in a graduated cylinder to get a precise amount.
So that means you want to put the whole water inside. So you want 250. So you want 200 ml. So are you going to put 200 ml? Are you going to measure? What are you talking about? In your second step, you say measure the amount of solution. What is that?
The solution of ions for that, like, because my teacher told me that it's like the only way you can get a precise measurement is to use a graduated cylinder. So like
okay. So you want to say you want to use the graduated cylinder and then
to measure the aqueous solution of the silver ions, because like by 50 ml each, and then pour that into
cancel that. What do you want to pour? Let's make this simple, guys. Okay, the more you make it complicated, it's very simple. First step, what? You use weighing paper, right? To what? To measure the mass. After you do the math, you use the weighing paper. Yes, Ananta?
You just use the volumetric flask.
Yeah. You want to use the volume because you want to make what? 200 ml of solution. Right? You want to make 200 ml of solution. You're going to use the 200 ml of volumetric flask. Okay? So it's something like this. Okay? This is, and there will be a line here. You're going to take that, okay? And in the second step, you take that, you're going to fill some water. That's it. So even if your sentence is so simple, it's better actually, okay? So what are you gonna say? We take what? The 200 ml volumetric flask, we fill some water into it. Okay? And then what? The third step, what are you gonna do? Remember when you weigh the mass of this? Put it in. Add the weight mass to the sum of the water, okay? It's not 200 ml yet. You don't directly give 200 ml. You can just say some water, it doesn't matter. Maybe you can put half like that. It doesn't matter. Okay? And then what do you do next? Do you see like how on the top it's kind of like that? So it's easy for you to swirl. Okay? And then what do? You swirl it. That means you're kind of like mixing it. Okay? Number 4, you swirl it to mix. Okay? You swirl to mix, to dissolve, whatever you want to say. Okay? Next, what are you gonna do? Now this is it. Okay. As long as you have those 4 steps already, give yourself 1 point. If you say you add up to 200 ml, and then you add the what solid, the wake solid, you're not gonna get a point. Yes, Saket?
Would it be correct to say, like, I just reversed steps 2 and 3? So I said step 2 was transfer AgNO3 to the 200 volumetric flask. Then step 3 was add enough distilled water to dissolve this. Then step 4 was swirl till it's fully dissolved.
Yeah, that should be fine. That should be fine. Okay, so as far as you have that, you still have half of the water there, right? Next, what you're gonna do? At step 5, which going to cost you 1 point. Now you add your water, remaining distilled water, up to the calibration mark. Okay? And then you mix it. You can put cork on it, you can put stopper on it, and then you can flip it and mix it. That's going to give you another 1 point. Yeah, Saket?
Can I say, like, I just added step 6 as stopper and invert the volumetric flask.
Yeah. Yeah.
Thanks.
5 and 6. Good. Make sense? Anyone want to ask? It's very simple, right? Add some water, and then what? Add the salt, mix it, add extra water up to the calibration point, and then invert it, flip it. Put stopper and then, okay? Okay. Yes, Ayana?
I was gonna ask if we could like use a pipette and like use it, like mix it by doing it using pipette and going like up and down with it.
Yes.
I don't get
Well, you can use the pipette. See, when you are at the calibration mark, right? If you want to make it very what? You guys know about meniscus, right? So if you want to make it very, it's not pipette. I don't think they used pipette. They used something eyedropper. Okay, not pipette,
Okay.
dropper. So if the dropper is included here, you can use dropper, okay? You can use dropper to make sure that the meniscus is exactly on the calibration mark. Okay, so don't use pipette, not pipette, dropper. But because they did not give you here dropper, you don't say that.
Okay.
Okay? Okay. Okay, now that's one. What do we know? One aluminum, right? One aluminum is going to what? One aluminum is going to go and okay, let's see what we have on this side, okay? I'm going to do BCA table, but in this BCA table, we only do whole number because we have to draw. So aluminum is 4. Ag plus is 1, 2, 3, 4, 5, 6, 7, 8. And then this is 0. See, which is your limiting reactant? So if you divide this by 1, you divide this by 3. This is you're going to get 4. This is you're going to get what? Around 2 point something something, right? So the whole number would be 2. Okay? Not round it up. Don't round it up, okay? You're going to get what? 2.67 maybe? Right? But just make it 2. Okay? Just make it 2. So which is smaller? The 2 is smaller. So you're going to put the 2 on the top. Remember BCA table? And then you're going to what? Take this, multiplied with the coefficient. So 1 multiplied with the 2 minus 2, right? 2 multiplied with 3 minus 6. And then 2 multiplied with 1 plus 2. 2 multiplied with 3 plus 6. Right? So this is 2, this is 2, this is 2, this is 6. Good so far? That means what? In the after, you're going to have what? 2 of aluminum solid, which they help draw to you, right? And then you want to draw what? 2 of Ag3 plus. Before we draw the plus, we can draw the solid first. How many Ag you gonna draw? 6. So do you guys see the size is a little bit bigger, so you can draw 6 of this, okay? Wait, I'll just... Sumit, you there? Okay, and then this is Ag plus. And then the remaining is going to be the what? The ion is going to be in the solution, right? So you're gonna have 2 of Ag plus. And what? 2 of aluminum 3 plus. Yes, Disha?
Wouldn't the Ag be solid? The
Oh,
6
did I
AG.
say plus? It's not supposed to have plus, my bad. It's not supposed to have plus. Okay. Now, okay. Yes, Anish?
Is it okay if you didn't like put the solids next to each other?
How do you do it? How did you do?
Like I just put like the Ag on like a different side of the beaker. Is that fine? Like I used the correct amounts.
But see, solid, they what? They clump together, right?
Yeah.
So that's the thing. You want to make them clump together. You have to make them together so it shows that it's solid. Okay? But the ions, they can float around. Okay, so the points. If you have, so you have what? 4Al, right? actually what? 4 AL. If you have 4 AL, total AL, okay? AL3 plus together with AL, and 1, 2, 3, 4, 5, 6, 7, 8, and 8 AG plus, in 8 AG plus, AG and AG plus, give yourself 1 point. Okay? So first one, let's say you really do not know how to do it. You still can conserve the what? You can conserve the number of atoms. Whatever total atoms on the left should be the same on the right. Gonna give yourself 1 point. Second, you're gonna calculate the charges. Now conservation of charges. Both the charges on the left side of the beaker and right should be the same. So here we have what? 1, 2, 3, 4, 5, 6, 7, 8. So you're gonna have 8 positive. Here, what do we have? 3 plus 1, 4. 1 plus 3 again, 4. So 4 plus 4, 8. So if you have both sides 8 charges, 8 positive, give yourself another 1 point. And at the end, you're going to see what? Did you have them in the correct state? That means clumping together. If you're Ag solid, you have what? 6 Ag solid clumped together like that, and 2 Ag plus and 2 Al3 minus. Then you give yourself another 1 point. Any question? For this one, you just have to calculate your E, right? Just have to calculate your E. So E equals to, see which one? This is going to be reduced. This is oxidized. The lower value is oxidized. Yes, Anvika?
I'm just letting you know that Tisha got kicked out of the Zoom, but she'll be back, I think.
Okay. So this one, the oxidized, you're going to what? Flip it and it will become 1.66. Now you just add those two together. One point. Okay, give yourself 1 point if you have that. Saket, are you checking your paper? You marking it down? Saket?
Yeah, me, yes.
Okay. Now, okay, Saket, F.
For F, I put, according to delta G is equal to negative NF E cell. Because E cell is positive, delta G it will be negative.
Okay. Also, when you say delta G is negative, you also want to say what? You want to say that means it's thermodynamically favorable. Okay? Okay, 1 point. Once the reaction appears to stop progressing, would the change in delta G be positive, negative, or 0? Disha?
I said that once the reaction appears to stop progressing, it reaches equilibrium. So the
Good.
change in voltage would be 0. So then that would mean the
Very
delta G
good.
is also 0.
Good job. Okay. When what? When it reaches equilibrium, that means what? Delta G would be 0. That's why the what? The reaction appears to stop. That's equilibrium, no? Okay. That's it for who got 8 and above. You guys can count.
Rita, I was kicked out of the Zoom. Could you go over the answer for D? Because I don't know.
For D?
Yeah.
Okay. You can go and check the recording, okay? Because it's already late, right? We also still gonna meet in the evening. I think wait, I did record this, right? Yeah. I did record. You can go back, okay? Yeah. Anyone 8 and above? Okay.
I just had a question.
Mm-hmm. Yeah.
This was out of 10 points, right?
Yeah. right? Which one are our 2 points? The delta, wait, no, that's not this one. The steps, and 3 points were for the diagram, right? Other than that, everything is 1 point. Okay. Finally, short question. Okay. Now, who wants to answer this? Again, another stoic, Inaya 2. Inaya 2. Wait, am I? This one.
What happened? Oh. Oh, for 4A?
Mm-hmm.
This one I kind of wasn't sure on.
This is gram per liter. Whenever you see this, you can kind of just like say what? For 1 liter, you have 0.0016 gram, right? And you have the molar mass, right? So you take them grams. Okay, you can take the grams. You can do 2 ways. You can do with stoic, or you want to do this simpler version. It doesn't matter, okay? So let's say you want to do with the stoic. You can start with 1 liter. And then what? This means what? 1 liter equals to 1 liter equals, whenever they give you like this, okay? Same goes with ampere stuff. Okay, same goes with ampere. Whenever they give you ampere, let's say they give you 5 ampere, make what? 5 coulomb equals to 1 second. Okay, so they gave you this, make what? This much of gram equals to 1 liter. And they did ask you for 1 liter, so over 1 liter times 0.0016 gram. Cancel the liter, you have the gram. And then to get the moles, you can what? Put the molar mass on the bottom, 1 mole on the top, right? Gram, cancel, that gives you 3.1, whatever that is, 366, okay? Don't have to think twice. Just put 366. 10 negative 5 mole. Any question? 1 point. Okay, B. Inaya 2. This is highly soluble. This is not very soluble. In what? In water. Explain.
Okay, I said that NH2Cl is polar covalent, is a polar covalent molecule that exhibits LDF and dipole-dipole, and NCl3 is nonpolar covalent that only exhibits LDF. And the NH2Cl would form stronger IMF bonds within the water, which makes it highly soluble, while the NCl3 is not as soluble because of the weak LDF it exhibits.
No. Okay, so the first point, you're gonna get first point if you have the correct IMFs. And listen, this is where students make the most mistakes on. You want to talk about the IMF between that particular molecule with water. So guess you can what? You can imagine you have water here. Think about how these two interactions will happen. Let's say you have another water here. Think about how these two interactions would happen. Okay, so when you have water here, and okay, the first point, you want to what? You want to mention the correct IMFs in between in both of this. Okay, so you can say what? NH2Cl will experience what type of IMF with water? Not with itself, with water. What type of IMF it will experience with water, Inaya 2? Inaya 2?
LDF dipole and a hydrogen bond.
Okay. Okay. Now, what about this?
For NCl3, I said
With water.
With water, LDF.
And LDF's everywhere. And dipole. Also hydrogen bond. Why? Because you have hydrogen acceptor. Water has hydrogen donor. There will be IMF hydrogen bond between those two. Okay. So basically you do have both of them hydrogen bond. The key here is that, again, this one has more hydrogen bond sites. Okay, so it can form hydrogen bond here. It can form hydrogen bond here and here. Okay, you're going to get for 1 point if you mention what? The IMFs between each of this with water. Okay, so you can say what? This gonna have LDF hydrogen bond dipole with water. This gonna have same hydrogen bond dipole with water. And LDF with water. That's gonna give you 1 point. Second point, now you just kind of just like have to what? Just have to say, oh, because there is what? More hydrogen bond sites in the NH2Cl, the IMF will be stronger, and then what? It will be higher in it will be more soluble in water. Okay, because the attraction is stronger, blah, blah, blah. Make sense? So mention, whenever this type of question comes, you have to mention IMFs. And then talk about their strength. Okay, because by now all of you already know it's not always dipole be stronger than LDF, right? Sometimes LDF might be stronger than dipole. Depends on the fact that you have. Yes, Ayana?
Does NCl3 form hydrogen bonds or no?
It does with water. It does not with itself. It does with water.
Oh, okay.
Okay, this hydrogen acceptor, this is hydrogen donor, they can form, right? Any other questions so far? So that's where you get 2 points. Oh, that's it, right? Oh, no. Okay, this one, C. For C, Estes again, stoic. You start with what? Given gram, convert to moles, and then multiply with this, right? Remember delta H equals to what? Q equals to M delta H, right? And M depends on what? The unit of delta H, because this is per mole, you have to convert the mass to mole. So 15.0 grams divided the molar mass, gram per mole, times delta H, which is 32.9 kilojoules per mole. That gives you 4.10 kilojoules. Any question? 1 point. Any question? Yeah, Rihanna?
I'm a bit confused why you divided it by 120.
Remember Q equals to M cat
Mm-hmm.
and Q equals to M delta H.
Mm-hmm.
What did I say about M? M can either be gram or mole. What does it depend on? Depends on the unit of C and delta H. Because the unit of delta H is per mole, you have to make it mole. How do you make it mole?
You divide it by the molar.
Gram divided by molar mass. Yeah. Anything else? Yeah, Sakit?
So whenever it's asking for energy, you use delta H, or you find delta H, right?
Q is energy. Delta H is enthalpy.
Enthalpy, okay. All right, that makes sense.
Okay. Q equals to, delta H equals to, if you rearrange, it's just like I want to give you guys as least formula as possible, because you guys already know this formula based on the phase diagram. That's why I'm just using this formula.
Okay.
Okay,
So if it asks for thermal energy, then
you're actually finding Q.
Q. All right.
That's what you're finding, Q.
All right. Thanks.
Oh, okay. Okay, this is so total of 4 points. 2 points for B. This is 1 point. Okay. Number 5. Okay, now based on the rate law, you know that this is first order because this is first order, right? Because this is first order means what? Means you can use the T-half formula. 693 over K. Now using that, you can solve for K. Well, there is multiple way to do this, okay? You can do the integrated rate law, but the best way is just to use this. Easier too, right? So K equals 2.693 over T half, which is, when do you get to half? 1.67. So 0.693 over 1.67 hour. And it's gonna be 0.415 per hour. 1 point. Okay, Ananta B.
For part B, this question, I said, since the given rate law has only N2O5 as a factor, we predict that the rate determining step is number 1, as N2O5 is the only reactant.
Good. Yes. Okay. And you want to say what? It's consistent. The wording, which is consistent with first order. Okay? Which is consistent with the order the what? The rate law given above. Okay? Okay, 1 point. If this experiment was repeated at the same temperature, but twice the initial concentration, would the value of K increase, decrease, or remain the same? Why? Yeah, Araf?
I said it would remain the same because the K only depends on the temperature.
Good. Okay, 1 point. Oh, sorry, I forgot here, okay? For number 8, it's actually 2 points. The second point would be your unit. Okay? For A, you're gonna have 2 points. The second point, if you have the correct unit, which is per hour. If you do not write your unit, minus 1 point. Because they did ask you to include the unit. Okay, this one. We already had one FRQ like this before, right? So which is the wave plan? The best wave plan? Anish?
525
525.
nanometers.
Yeah. Good. 1 point. The highest point, okay? 525 nanometer. Now, okay, next. Sharvari. This is the meniscus that I was talking about, okay? This is the meniscus. This is where you start to read. Okay, Sharvari, read. What's your answer for 1?
I said 20 sorry.
20?
Sorry. 90.20 milliliters.
90 point? Wait, you sure? This is 90. This is 100. It is divided into 10 gaps. That means this is 91, 92, 93, 4, 95, right? Right? So?
Yes, I accidentally wrote down the wrong number.
Okay, Inaya too? What's the number?
For
1.
I? Oh, okay. Wait. 92.0.
92.0. If you miss the 0, minus 1. You cannot miss the 0, okay? Whenever what? You have the 2 lines, but you always have to guess extra decimal. Okay, so 92.0. Okay, number 2, this is just a dilute. Yes, Ayana?
Does the extra value after the decimal have to be 0, or can it be?
You can make it 1, that's fine too.
Okay.
But don't you think this is exactly on the line though? No? So does it make sense to make it 0.1? But okay. Number 2. M1V1 equals to M2V2, right? Dilution, right? So V1 M2 times V2 over M1. In this case, you don't have to change the volume into liter, okay? As long as you just need to know, oh, I use ml here, so my answer also gonna be in ml. So 70 ml. 1 point. Okay, we also did one question like this, remember? It was also below the graph. Oh no, it was fingerprints though. Okay, but okay. Now, which step did the student messed up? Anam? Which step the student messed up? These are the correct steps, okay? Which the student has what? Design. The design is perfect. But there must be a step that the student did not do correctly. Yeah, Saket?
So I put step 3, and this is because the concentration of the standard solution may be less, or that the standard solution was filled within the cuvette too little. Both discrepancies in step 3 would result in lower absorbance.
Yes. Yes,
Okay.
correct. So basically what? Well, basically the student did not rinse it properly with the standard solution. Okay, that's it. That's why there's still water. Okay, because there is still water. That's why the what absorbance is lower than expected. Yes, Ayana, Inaya too.
Would it count if you said in between steps 2 and 3, or did you have to give like one step?
You have to give one step.
Okay.
What is in between 2 and 3? No?
I just said in between steps 2 and 3, the student didn't dry
But
the
the
correct.
student, the drying part not here though. Right? There is no drying.
Okay.
Okay, yeah, Saket.
Would it be fine? Like, I didn't mention rinsing at all. Like, it didn't rinse it. I just said that the concentration is less.
You have to it's still fine because the teacher would assume you know it's rinsing, but you actually see what happened. What actually happened here? So for this is the cuvette, right? You want to put the solution here with a specific concentration. Let's say the concentration is 1 molar. Before you do that, you have to wash it, right? So you wash with what? Distilled water, and then you dry it. But there's still be a possibility where there's gonna be still water droplets, like very tiny, minute, right? So what can you do? You have to rinse with the solution that you're gonna use.
Yeah.
Okay, you have to go back and rinse with the solution you're gonna. So basically, that solution gonna coat it the what? The cuvette. Okay, because the student did not do that part properly, that's why there's still some water left that cause lower absorbance. Okay, and that is 1 point.
Thanks.
Oh yay, last one. Okay. Okay. Hybridization. Harshit, how do you know hybridization?
Okay, so for this one, I looked at the amount of like like I guess like electron regions that
Good.
D had. So since
Okay.
it has two single bonds and one double bond, I said the hybridization was sp3.
How many electron regions?
Oh, three
Electron
electron
domain?
regions. Three.
Okay, yeah. 1, 2, 3, right?
Mhm.
How
Yeah.
many atoms? The simpler way is what? The simpler way, how many atoms connected?
Mhm.
Atoms connected plus lone pair on it.
Yeah.
Okay, so this is sp2. Okay, 1 point. Write the expression. Well, okay, what did I say, guys? Whenever there is KSP, you do what? You take the solid, you take the salt, split it up into their ions. Always, no matter, even though they did not ask you to do so, just do it. It's for your own sake. Now, because you see KSP and then because they did not give you the reaction, but you know that what? You remember I said whenever you see KSP, split them up. You did that. Now you can what? Easily write your KSP expression, right? Product over reactant, reactant solid, you don't care. Square C2O42 minus, right? And then how do you get the molar solubility? You do I-stable. Remember? I don't care how many times your teacher say you have to remember this for this type of formula, that for this type of formula. The simplest way is just to do the I-stable. 0, 0 plus 2x. Because this is solubility, you can put instead of x, you can put s if you want plus s, 2s as, and then what? KSP equals to AG, which is 2s whole square, time s. You have the KSP value, you plug it in, and then you can solve for x. 5.4 times 10 negative. Yes, Ayana?
Does it matter if we use S or X?
No, it does not.
Or
It does not. But it's better because, but make sure you just like at the end, make sure you say it's S, okay, solubility. Okay, and then you do S equals to 5.40 10 negative 12 divided by 4, and then cube root. That gives you 1.11 10 negative 4 molarity. Okay? Make sense? The molar solubility increases when it is dissolved in this instead of neutral water. Write the balance equation that happened in here. Again, for this, what did we say? Strong acid dissociate completely. So this is going to be H plus ClO4 minus. Right? And what? The H plus is going to go, I mean like, this H plus is going to go what? React with the C2O42 minus, right? This thing. So H plus plus C2H42 minus becomes HC2. Wait, this is O4 minus. If you have this, you're good. Okay. Yeah. Wait, Ananta?
Did we have to show that the AgC2O4 is also solid, so Ag2C2O4 in the ionic equation, or is that just C2O4 2 minus?
Just this.
All right.
Okay, because when you dissolve, this is gonna go react with whom? It's gonna go react with the H plus, of course, is gonna go react with this part, no? Yeah. Sakit?
I thought that it would have been like whatever forms a precipitate, because if it forms a precipitate, that ion is being taken out of the equation. and then it'll go the other way then, right?
You are adding something else to it. You are
Yeah.
adding something else to it, right? So what's your answer? Tell me.
I didn't even like finish it really. I just put 2Ag plus 2 ClO4 minus gives 2Ag ClO4.
See, okay. See, they're asking you how does this going to affect the solubility of this. Okay, listen. They're asking you how this is going to affect the solubility. Okay, so what's gonna happen? The H plus, it's a strong acid, right? So the H plus is gonna go react with this, right? It's gonna go react with this. And then that means what? This amount's gonna go down. Common ion effect, no? It's gonna go down and it's gonna go to the right. Okay, so they wanted you to show that specific reaction. Instead of asking you what happened when this is added to this, right? They ask you to go and write the equation that's gonna happen. Yes, Anish?
I was wondering if you could write 2H plus and then do like
Yes.
H2CO4.
Yes.
Okay.
Yes. As long as you have the reaction show that the H plus of this go react with this, you're good.
What about if Ag reacts with ClO4?
CgO4 minus. That is that. What would that? Oh, ClO4 minus.
Yeah. Yes.
Wait, chlorate. See, give me a second.
Huh.
Isn't chloride always soluble? Yeah, it is soluble. So it's a what? Spectator.
Let's see. So you have to get the one. So then HC2O4, is that not soluble?
It is not fully soluble. This is not strong acid.
Oh.
No?
Okay, that makes sense.
Any other
Yeah.
question? Okay, so we're gonna meet again today at what's our normal time, 8 p.m. Eastern, 5 p.m. Pacific. And you guys can come to me with your own questions, okay, if you have any question. Also, we're gonna have, tomorrow we're gonna have extra session, like a cram session. Okay, so the timing is 11 Pacific, 2 p.m. Eastern. Okay, please note it down. So it's gonna be a cram session where we will go over each topics, just like the important things or the things that you guys are struggling with in that topic. So make sure to already do your own studying and then come to me with questions, okay? Like, oh, I don't understand this thing, that thing. Okay? Anything else for this paper? Oh, okay. So count your points. Go ahead. It's supposed to be what? 46. Out of 46, how much you got? Count your points and text me. And let me know if anyone got above 36 points. Count it, Vanessa. Araf counted above 36. Izai, Rajin counted, okay? Sanvika, Twisha, Max. Okay, good job, Anish. Okay, put your text me your grade, everyone. Text me your score. If you have 36 and above, that's a 5. Okay, that means that's 78%. Text me your grade, please, so I know. Also, I'll see you guys today's evening, okay? Bye-bye. Thank you.